All right, so this video is going to be how we take the second derivative with implicit. So first off, we have to take this first derivative in order to get to the second derivative. And this first derivative, we're going to have to use our implicit differentiation because y is not solved for. All right, so x squared plus y squared equals 25. Take the derivative of each individual piece. So the derivative of x squared is going to get me 2x. And now we have to use chain rule when we get to the derivative of y squared. So the derivative of y squared is your outer function first, which is the 2. So we're going to get 2y. We have to multiply it by the derivative of our inner function. The derivative of y is going to get us that y prime. And then, of course, we're going to have to take the derivative of 25, which is 0. Now, from here, we need to solve for that y prime. So I'm going to subtract the 2x to both sides, and I'm going to get 2y, y prime, is equal to negative 2x. And then I'm going to have to divide out the 2y. So I divide by 2y, I get negative 2x over 2y. I'm going to simplify that, and my first derivative is negative x over y. Now we're going to take the second derivative of that, right? So y double prime is equal to, now when we take the derivative of negative x over y, we have to use our quotient rule. So I'm going to go low function times the derivative of my top function, so y times negative 1, minus my top function times the derivative of my bottom function. Now the derivative of y is y prime. And we're going to divide that by our bottom function squared. All right, I'm going to do some multiplying out here. So I get negative y plus x times y prime all over y squared. Now what I'm going to do from here is we cannot have a derivative inside of another derivative. So y prime needs to be changed. We already know what y prime equals. It's negative x divided by y. Before I start to substitute, what I'm going to do is I'm going to break up this fraction. I'm going to break it up into two separate pieces. I'm going to write negative y divided by y squared, and then I'm going to take my x over y squared and multiply it by that derivative of y prime. Right? So I can do this because it's all algebra techniques. So I'm separating my two fractions that I add together. So I got that common denominator of y squared. Right? My second fraction needs to be multiplied by that y prime piece. Right? Now all I have to do is substitute what y prime equals. So negative y over y squared plus x over y squared times my y prime, which is negative x over y. All right? So at this point, I can actually rewrite that x over y squared times negative x over y. I can go ahead and multiply those two fractions together. I get negative y over y squared plus, or actually minus this time because I'm taking a positive and multiplying it by a negative. All right, and I get a negative x squared over y cubed. Now, you can leave it like this if you want to evaluate, but if you want to simplify, you can go even further. You can go ahead and get a common denominator. Common denominator would be y cubed. So my left fraction, negative y over y squared, needs to get multiplied by y. So I can finally write this as negative y squared minus x squared all over my common denominator, which is y cubed. And that's how you take the second derivative using implicit differentiation.